Ladies and gentlemen, boys and girls, welcome to another edition of Prime Factorization. That's right, today we're going to be talking about prime factorization using a factor tree. To do that, we're going to simply start out with a factor pair. What's two numbers multiplied together to equal 24? Now I know what you're saying, you're like, there's multiple numbers that do that. Well, choose your favorite. In this case, my favorite is going to be 2 times 12. I know that 2 times 12 equals 24. Now, because 2 is prime, I can bring that down. And because 12 is composite, I got to break that apart. What two numbers multiply together to equal 12? That's right, folks. We know that 3 times 4 is 12. Because 2 is prime, we're going to carry it down. Because 3 is prime, we're going to carry it down. And because 4 is composite, we are going to break it apart. What two numbers multiply together equal 4? That's right, folks. 2 times 2 equals 4. And thus, we have found the prime factorization of 24. Now, you know you've done it right if you can multiply all these numbers together and get 24. So 2 times 3 is 6, 6 times 2 is 12, and 12 times 2 is 24. So we have the prime factorization of 24. And you can see that it makes a little tree. Should we do another one? Let's do another one. Okay, so let's break 30 apart into our favorite factor pairs. Probably my favorite one at this point is going to be, let's do 3 times 10. 3 times 10 is 30. Now, because 3 is prime, let's go ahead and bring that down. And 10 is composite, so we break it apart. What's two numbers multiplied together to equal 10? Well, we know that 2 times 5 equals 10. And oh, looky here, we have nothing but prime numbers on the bottom, which means that we have found the prime factorization of 30, providing, of course, those numbers on the bottom multiply together to equal 30. 3 times 2 is 6, and 6 times 5 is 30. The prime factorization of 30. Let's try 16. First, we're going to choose our favorite two numbers to multiply together to equal 16. The question is do you like 2 times 8? Or do you like 4 times 4? I like 4 times 4. You know why? For a very good reason. Because look how nice and even that looks. And check this out. 4 is composite. So we're going to break it apart by multiplying 2 times 2 is 4. And we're going to do the same thing on the other side. Check it out. 2 times 2 is 4. And we have a perfect factor tree. Hold up, I need to make a tree. It's not even Christmas yet, y'all. But it looks really cool. Wait, hold up. I need to make a little... Anyways, that's the prime factorization of 16, and now we're moving on to 48. Let's go ahead and break it apart into our two favorite numbers that multiply together to equal 48. Do you like 2 times 24? Or do you like 6 times 8? You know, there's probably, I wonder if there's more, I don't even know, but I like 6 times 8. 6 times 8, that'd be great because I get 48. 6 times 8, doo-doo-doo. Look at this, everything's a song with me. Now, 6 is a composite number, so let's go ahead and break that apart. What two numbers multiply together to equal 6? Well, I know that 2 times 3 equals 6. And now I got to break the 8 apart because that is also composite. What two numbers multiply together to equal 8? Well, I know that 2 times 4 equals 8. Well, this is prime, this is prime, this is prime, and this is composite. So let's break it apart. And we know that 2 times 2 is 4. Now let's double check this one. Make sure that everything multiplied together equals 48. 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. And 24 times 2 is 48. It works. We have the prime factorization of 48. But I know what you're saying. You're saying, but I don't get it. But I need another example. Well, don't you worry. Don't you fret. I have got your back. Just relax. Everybody breathe. In through the nose, out through the mouth, because we're about ready to take 45 down south. As we do the factor tree from top to bottom, what two numbers multiply together to equal 45? That's right. 3 times 15 equals 45. But I know what you're saying. You're saying, but couldn't we have just done 9 times 5? Of course you could, my dear friend. As long as the bottom numbers are prime and they multiply together to equal 45, it doesn't matter what you do. Maybe it does at some point, but as far as I know, I think we're good. So, let's do 9 times 5. 9 times 5 is 45. 9 is composite, so let's break it apart. We know that 3 times 3 equals 9, and 5 happens to be prime. So we carry it down and make this lovely tree shape, but let's check and make sure that we have done it correctly. 3 times 3 is 9, and 9 times 3 is... Wait, what did I do wrong? 9 times 5 is 45. 3 times 3 is 9. Oh my goodness, it's getting a little bit late. 3 times 3 is 9, and 9 times 5 is 45. You guys, I might want to stop. But I can't be stopped. Let's do one more. We're going to do 20. Let's break it apart. Do you want to do 2 times 10? No. Do you want to do 4 times 5? Yes. Okay, let's do that. 4 times 5 is 20, and that's composite, so let's break it apart. 2 times 2 is 4, and that is prime, so let's bring the 5 down. And let's multiply these bad boys together. Make sure they equal the top number. 2 times 2 is 4, and 4 times 5 is 20. Thus, the prime factorization using a factor tree has been demonstrated to you by me. I hope it was helpful. If it wasn't, I'm really sorry. I tried.